Hey guys, thanks for watching. Thought I'd upload a short little video just kind of going over some things that people have questions about since I'm not able to go live tomorrow. But I will be going live on Facebook Friday at 1 p.m. So just a little review first off. Okay, so just a simple thing. So if we got 2 times 2, we know that's going to be 4. Okay, just multiply the two numbers together. So if we have 2 times 2 times 8, you know, you can multiply all 3 of them together. You do 2 at a time though. Okay, so 2 times 2 is still 4, and then we still have this times 8. 4 times 8 gives you 32. Okay, so this whole thing's going to be 32. So if we look at square roots, everything underneath the square root will multiply together, and everything not underneath the square root will multiply together. So like this one, if we have square root of 3 times square root of 2, you can just put all of it under one square root. 3 times 2 gives you square root of 6. Okay, so anything underneath the square root can be multiplied together if they're being multiplied. So if you have square root of 3 times square root of 2, it's just square root of 3 times 2. You can put everything underneath the same square root. And then sometimes you have things like square root of 2 times square root of 2. Okay, so you can do the same thing again since they're both underneath the square root. Put them underneath the same square root together. 2 times 2, keep the multiplication there. And then that's just going to give you square root of 4. But the square root of 4, well, it multiplies by itself to give you 4. It's just going to be 2. So if you multiply the square root of something by the same thing, the square root of something, so like square root of 2 times square root of 2, square root of 6 times square root of 6, you're just going to get the same thing that's underneath the square root. So like 2 in this case is what's underneath the square root. So our answer is going to be 2. So if we have something that has a number outside of the square root, for example, so if we have like 2 square root of 5 times square root of 6, okay, it's a times sign, sorry. Then we have everything that's outside of the square root, so we'll take this 2, and then everything that's inside the square root goes underneath the square root together. So 5 and 6, again, they're being multiplied. So like that. We keep everything that's outside the square root, and then everything that's underneath it. 5 times 6 is going to be 30. Whatever's outside the square root stays on the outside, and whatever's underneath the square root stays underneath the square root. So I am going to mention this only works for multiplication, okay? Multiplication and division. Do not do this if you're adding or subtracting. Only put the things together underneath the square root if you're multiplying or dividing. For example, if we have something like 5 square root 2 times 8 square root 3, that sounds good. Then we're going to take the things outside of the square root. So we have a 5 outside the square root and an 8. We'll go ahead and multiply those two together on this part. Then everything that's underneath, so the 2 and the 3, we're going to put underneath one square root and multiply together still. Okay, so 5 times 8 is going to give you 40. And then for the square root, we have that 2 times 3, 6. So we can just leave it as 40 times the square root of 6, or 40 square root 6. We don't have to actually do anything with the 40 and the 6 together. We just keep whatever's outside of the square root together and whatever's inside the square root together. Okay, so let's take another look at rationalizing fractions. So let's look at an example like 3 over square root of 2. Again, we only rationalize whenever we have a square root on the bottom of a fraction. We want the square root to be on the top of the fraction. So instead of this, we are going to multiply top and bottom of the fraction by whatever square root you have on the bottom. Okay, so in this example, we're just going to multiply straight across. So 3 times the square root of 2. Outside is 3. 2 is underneath the radical. Then we have square root of 2 times square root of 2. Okay, so we're going to put the 2's underneath the square root. We can go ahead and simplify that. So 3 square root of 2 doesn't change, but that changed to the square root of 4. And if we say what is the square root of 4, it's going to be 2. So we can just go ahead and simplify to that. So to rationalize, to get the square root on the top, you just multiply the top of the fraction and the bottom of the fraction by whatever square root you have on the bottom of the original fraction, and then simplify. So another example of how it might play out is if we look at 15 divided by the square root of 3. Okay, so what we have on the bottom here is the square root of 3. So we're going to multiply the bottom by the square root of 3 and the top of the fraction by the square root of 3. Okay, and then for there, 15 square root of 3 Can't do anything with that because there's only one thing on the outside of the square root and one thing underneath the square root. But on the bottom, square root of 3 times the square root of 3, we can take those 3's and put them underneath the square root. If you want to skip this step, you don't have to write it all out. So now we have 15 square root of 3 on this top still, and then 3 times 3 gives you 9 underneath that square root on the bottom. And again, the square root of 9 is 3. Okay? Now we can write it this way, or we could also take it this, so 15 divided by 3 times the square root of 3. And if we want to, we can go ahead and simplify that, because 15 divided by 3 is just going to be 5, which is where we get 5 square root of 3. So again, multiply the top and the bottom of the fraction by whatever square root you have on the bottom of the fraction. Simplify the best you can. That's all you got to do. Okay, so now we can go into some actual special right triangles. These are all going to be problems from the paper that you're getting today, Tuesday, but these will also help you with the problems if you didn't understand anything yesterday. So I'm going to go ahead and write down that if you have a 45, 45, 90 triangle, okay, so the leg is going to be just whatever value it is, a, and then the hypotenuse is going to be a times the square root of 2. And then if you have a 30, 60, 90 triangle, you know that the shorter leg is going to be a, the longer leg is going to be whatever the shorter leg is, so a times the square root of 3, and then the hypotenuse is just going to be 2 times whatever the shorter leg is. So I'm going to go ahead and keep that up there. So if we look at number 1 on the paper for today, it's going to look like this. Okay, so we can see that it is a 45, 45, 90 triangle, and we have that these are the legs, and this is clearly the hypotenuse, because it's directly across from the right angle. So now that we've labeled the sides, we know that the 2 legs are going to be the same. So we already know that x is also going to be 13, since this one's 13. And we know that just whatever the leg is equal to a. So in this case, leg is 13, so a is 13. From that, if we're looking for the hypotenuse, we can take the fact that the hypotenuse is equal to a square root of 2. Okay, we know that a is 13, so instead of writing a, we can write 13. Okay, and then square root of 2, and that's all you need. So this hypotenuse, y here, is just going to be 13 square root of 2. Let's take a look at number 2 next. So this one is another 45, 45, 90 triangle. The one across from the right angle is going to be the hypotenuse, and the other 2 are going to be the legs. Okay, so the legs, again, are equal to a, but it doesn't give us what the legs are. It gives us the hypotenuse. So this hypotenuse, which is 30 here, is equal to a times the square root of 2. Okay, and if we're looking to solve for a, we have to divide by the square root of 2. So if we divide by the square root of 2, those are going to cancel out, giving us that a is equal to 30 divided by the square root of 2, which we can rationalize. So if we multiply the top by the square root of 2 and the bottom by the square root of 2, okay, then it's going to give us 30 square root of 2 on the top. 2 and 2 are both underneath the square root, so 2 times 2 is going to give us 4. And then that's going to give us 30 divided by 2, square root of 4 is 2, times the square root of 2, which, if we do 30 divided by 2, you can get 15. So 15 square root of 2 is what a is. I'm going to write that out down below so we can kind of see it better. Okay, so now we know that the hypotenuse already is 30, and both of the legs is just going to be whatever a is. So x and y are both going to be 15 square root of 2. Okay, so now if we turn to number 4, so here we clearly have a 30, 60, 90 triangle. So we have to label the long leg, the short leg, and the hypotenuse. Across from the right angle is always the hypotenuse. Then you can clearly see, just by looking, that this one's going to be the long one, and this one's going to be the short one. But if you can't tell, the long edge is always across from the 60-degree angle, and the short edge is always across from the 30-degree angle. So we have the hypotenuse, so this 34 is going to be equal to whatever the hypotenuse is equal to. So if we look at the 30, 60, 90 triangle, it's just going to be equal to 2a. So if we're trying to solve for a, we just have to divide by 2. So a is 17. With this, we can solve for x and y. So x is the long side, so the longer leg is going to be whatever a is times square root of 3. So a is 17, so we're going to have 17 square root of 3. And that's going to be your answer for that one. If we look for y, it's the shorter leg. That's just going to be equal to a, and a is 17, so y is just going to be 17. Next, we're going to look at number 6. So again, we can tell it is a 30, 60, 90 triangle. Okay, across from the 90-degree angle is always the hypotenuse. Across from the 30-degree angle is the shorter leg. And across from the 60-degree angle is the longer leg. So we have that this longer leg is equal to 25 square root 3. And the longer leg, if we check the 30, 60, 90 part, is equal to whatever a is times the square root of 3. So to solve here, we have to divide by the square root of 3. Okay, and usually that would cause us to have to rationalize, but since we have square root of 3 on the top and bottom of the fraction, we can cancel the 2 out. It's just going to give us that a is equal to 25, so that made things a little easier for that one. So now we can use that to solve for x and for y. So x is the hypotenuse, which is just going to be 2 times whatever a is. You can get that from up here again. So 2 times this 25 is going to give us 50 for x. And then if we're looking for y, we have it as the short leg, and it's just going to be whatever a is. So it's just going to be 25. Okay, so we're now going to look at number 13 on the problems for today. Okay, so this is what the problem actually looks like. I've actually split this up into 2 separate triangles. So I've taken this 45, 45, 90 triangle, I've drawn it here. And I've taken this 30, 60, 90 triangle and I've drawn it here, okay, to make it a little easier to see them separately. This one, the 30, 60, 90, is the only one that actually has a side length, so we're going to use it. So across from the right angle is going to be the hypotenuse again. Across from the 60 is going to be the long leg. And then across from the 30 is going to be the short leg. Okay, so we have the length of the short leg. So this short leg is going to be equal, if we check the 30, 60, 90 triangle, to a. Okay, so this one's just going to be 17. So a is 17 on this case. So now, if we need the long leg, x is the long leg, whatever a is times the square root of 3. Okay, so 17 times the square root of 3 is going to be what this x is equal to. And then if we're looking for the hypotenuse, which we don't really have a variable for, the hypotenuse is going to be equal to 2 times a, which is going to be 2 times 17, which is going to give you 34. So this side is 34 here. And if we mark it here, okay, so that's this side right here. Sorry, it makes that line on top. But it also shows us that that's this side on that triangle. Okay, so make sure you get the side of that one, and then we transfer it over to the other triangle. So now we have a 45, 45, 90 triangle to work with. Okay, so I'm going to split these up. You can see that's the work for that triangle. I'm going to work for this triangle over here. So since this is a 45, 45, 90, the 2 sides that go off of the 90-degree angle, this right angle here, are going to be the same. So we know that z is going to be 34. Okay, so these are the legs. And this is the hypotenuse of this triangle, because it's across from the right angle. It gives us the length of the leg, so this leg is 34, and the leg is just equal to a, okay? So this is just going to be a. A is 34 here for this triangle. Now if we're looking for the hypotenuse, I'm going to say it's y, because we have y written here for the hypotenuse. If we check, the hypotenuse is going to be a square root of 2, okay? A is 34, so it's just going to be 34 times the square root of 2. That's all you have to do. When you have a problem like this, separate it into different triangles. So how I separated into this 30, 60, 90 and the 45, 45, 90. Treat them as different triangles. Make sure you transfer the numbers that you solved for. So each leg or side that you have, transfer it to the other triangle, and then just solve like you usually would on the other problems. So again, thanks you guys for watching. I really appreciate it. I hope this helped a lot. Again, I'm sorry I couldn't go live. I will go live Friday at 1 p.m., so make sure you block out that time. Message me any questions you may have on this stuff, and I hope this helped a bunch. I'll see you guys tomorrow for a new topic.